Recording. Shh. Quiet down. Shh. I'm recording. So, exercise 7B. You're going through equivalent equations. Shh. Equivalent equations. So what is that? In this chapter, chapter 7, I'm going to teach you what we call balancing the equation. So I'm going to write it here. Your technique... Oh, what happened? Oh, this pen died. That's my bag.
That's not good.
That's not good. I need a new pen. Alright. Here we go. I'm going to write it down. So we need to be going through a technique called... Hey, excuse me. Your eights. Thank you. What are my 3 rules? My 3 rules. Don't speak while I'm speaking. And don't speak while someone else is speaking. No throwing. 3 rules. Out of respect. Here we go. Balancing the equation. Balancing the equation. That is the technique that you'll be using all the way up until year 12. And even till this day, I'm still trying to teach my seniors how to balance the equation right. I'm trying to remind them that it's the technique. You guys have been training question, method, answer this whole entire year. It's because I'm trying to make sure that you have a layout that's very clear. So I'll show you something that I'm going to teach my year 11s today. And it's pretty intense because if you don't have your layout correct, it'll be very confusing on what you need to do. So I'll show you. This is probably one of the hardest exercise that they will do this term or this year. And it looks something like this. Let me just zoom down because it's quite a bit. Here we go. This one question. Have a look. This one question is what they need to do. I had to go through this. This took me 25 minutes to explain all of it to them. But usually it takes me about 9 to 10 minutes to sketch. So they have to be able to do this type of graph. They have to do this one technique, which is what you're starting on with in chapter 9 later, this term. And we went from that to the next part, which carries all the way through down to this many solutions, down to this many solutions. Now, you can't do that with your mind. You have to do it with layout. So when you see what I'm doing here is question, method, answer. I start off with the problem, and then I start moving down. Everything that I'm doing here that you see here is called balancing the equation. What you're starting off is in year 7 to 8. You're doing the most basic form. Then as you get better at it, this is what you're going to be doing. See, every step I do, I'm doing an inverse. I'm showing the steps, what cancels out. At the year 11 and 12 stage, this is the level that you have to get at. So if you skip your steps, this is what becomes a problem. Most students will find this tricky. So when I train you, I've been training you throughout the year, and I like it when I see question, method, answer, because you will be able to follow your steps and you can proofread where you've gone wrong. I made some mistakes while I was making this video as well, and I was able to backtrack and say, oh, where did I go wrong? So you need to be able to lay it out very clearly. So I'm training you at year 8. You have 4 years, or technically, about 4 years to get ready for that point. Okay, so that's what the training is. So you're starting off with what we call balancing the equation. How does this work? It's a very simple idea, okay? But it's all about question, method, answer. Here's the idea. 3 equals 3. I'm going to start off with this idea. Very simple, right? This is a statement. I want you to understand that when you write this symbol equals, listening, this symbol equals is very important. Why? Because you're saying whatever's on the left-hand side, it is exactly the same as the right-hand side. But what you have to also understand, it doesn't have to be the same number. You see, 3 equals 3 could also be written as 1 plus 2 is equal to 3. This statement is still true. I haven't changed that. That statement is still true. 1 plus 2, though it looks different on the left-hand side, it is still equivalent to the right-hand side. So, it's kind of like that idea. Have you ever heard that joke where they say, like, which one's heavier, a kilo of bricks or a kilo of feathers? Yeah. And we'd normally say a kilo of bricks, but really I just said a kilo of bricks and a kilo of feathers. It doesn't matter whether it's bricks or feathers, the fact that they're both a kilo, it has to be the same. This is the same idea when you say 3 equals 3, or 1 plus 2 equals 3, or what you're going to see over here, you see these equations here are all saying the same thing. They're saying, I don't know what x minus 4 is, but it doesn't matter. They're saying that whatever's on the left-hand side, it is equivalent to the right-hand side. Both of them are balanced. That's what they're trying to say.
Would it be 20?
Yes, the answer is 20. That is correct. Now, what I'm interested in was not the answer, boys, but more so, well, why do we need to know that it is equal? Why is that so powerful? This is what I want you to see. If this statement is true, okay, if this is true on a logical sense, what happens if I decide to put 1 on the left-hand side of this scale? So if I said 3 plus 1, if I added 1 to the 3 on the left-hand side, what does that equal to? What is 3 plus 1 equal to? 4. 4. But let's have a look at this. 3 plus 1 equals 4, but then the right-hand side, is this now true?
No.
No, this statement doesn't make sense. If you add 1 to the left, it becomes 4, but the right-hand side still remains as 3. This is now false. So how do you make it true? How do you ensure that they're both still going to be the same? If I add 1 to the 3, what else do I have to do?
Do 1 to the other one.
You have to add 1 to the other side. And this is where, when we say what you do on one side, you have to do to the other. The reason why is because it makes sense. If you don't do that,
It's false.
the statement wouldn't be true. This is still, again, true, even though 3 equals 3 and 4 equals 4 are different statements. Okay, so what I want you to understand here on a theoretical sense, 3 equals 3 is a statement. 4 equals 4 is another statement. But they're both equal. Okay? They're not unequal. When they're unequal, that's wrong. So when you're making a balance in the equation, when you're solving for this, what I'm more interested in is, have you kept it balanced? Is every line the same line when you're going from one to the next line? That's why I keep telling you to do it vertically. Okay? I keep saying, make sure your question, method, answer is vertical. Now, this also means you don't have to add a 1. You could decide to add a smiley face. That's okay, as long as you add a smiley face to the right-hand side, it is still balanced, because then they're the same. It's 4 with a smiley face, 4 with a smiley face. That means both sides are the same. It doesn't matter what you do, as long as whatever you do to one side, you do to the other. Which explains why when I go to my year 11s and 12s techniques, it doesn't matter how you do it, you just got to balance it correctly. So here we go. I'll give you an example now. So I want you to copy these examples. Let's do the first one. Logan said the answer was 20, or he asked, is it 20? Yes, the answer is 20, but I'm going to show you how many different ways you can do it. You can do so infinitely many ways to get to the same answer.
What if you don't know that this is 20? What if it's just a false?
Correct. Well, how do we prove that it's going to be 20? That's another question. Okay, so it's all about, you have to be able to prove it. If you can't prove it, how do you know it's true? Right? So here we go. We're going to start off with the first question. A, x minus 4 equals 16. What you're saying here is you're saying the left-hand side is equivalent to the right, even though they don't look the same.
Yes.
Your job is to balance it in some way. Eventually, you want to find what x equals to. Now, Logan's saying it's 20. Okay? Now, you can guess that. You can try, oh yeah, something take away 4 gives you 16. You're like, is it 20? 20 minus 4? Yeah, that's true. 20 minus 4, does it equal 16? Yes, they both equal 16. That's true. So that works. But what's another technique? What's another way? And this is what I mean. You can do this. You can decide to do this. You can add my favorite number. My favorite number is 3, right? So I can say, all right, how about I add 3? Now, if I add 3 to the left, what do I have to make sure? 3 to the right. So if I add 3 to the right, so let's work it out. Negative 4 plus 3, what does that give me?
7. Negative 7.
No, not negative 7, be careful. Negative 1, very good. Use the number line. So here, you have x, negative 1 is equal to 16 plus 3. What's 16 plus 3? 19. I was a bit worried about you guys there. So, here you have x minus 1 equals 19. It's not wrong. When you're working with algebra, it's rarely that you're wrong unless you added wrong or you minus wrong. Otherwise, if you keep it balanced, it's okay. X minus 1 equals 19 is still true. I haven't done anything different to it. Now, because I added 3 and I added 3, I can choose another one. I could say, why don't I try now add 1? You can add 1. There's nothing wrong with that. If I add 1 to both sides now, let's see what this ends up being. What is minus 1 add 1? Very good. 0. So, this becomes x plus 0 is equal to 19 plus 1? What's 19 plus 1?
20.
20. Now, can you see, I'm just balancing the equation. 16, I added 3. Gave me 19. 19, I add 1. I get 20. And x plus 0 is x. So what you can see here, I got the same answer. Thank you. You can see that I went through 2 random methods here. I said, let's add my favorite number. Let's add 1. And I still get to x is equal to 20. So what I'm trying to say is you didn't have to do it this way. You could have done so many other ways. You could have done 16 plus the 4. So we went through what James is saying here. We've got x minus 4 is equal to 16. James is saying you can add 4 on both sides. So we're balancing the equation. I add 4 on the left, I add 4 on the right. Well then, negative 4 add 4 is 0. You got x plus 0 is equal to 16 plus 4, which is 20. And again, same thing. That's another way. Now, since there are so many ways that you can get an answer of 20, listening, there are many ways to get an answer of 20. There are many ways to get an answer of 20. You're never wrong. Okay, you have to understand when you're saying, oh, I've done something wrong, you haven't done something wrong. It's not that you can't do algebra. You can. It's just how do you do it most efficiently? There is generally a technique. Now, what you've learnt in year 7 is what you call BODMAS, right? So you learnt
Brackets, operations, division.
Good.
Addition, subtraction.
Very good. Now, when we go backwards from this, when we're undoing this problem, because the order goes 1, 2, 3, then 4, when you're going backwards,
4, 3, 2, 1.
correct. Sam, Dob.
Wow.
Okay?
Wow.
So,
I've never heard of Sam.
yeah, I know. Well, now you're going to learn Sam, Dob. So, how does Sam, Dob work? This is how it works. I'm going to show you. You just got to copy it down first. So, let's do another problem here. And I'm going to show you Sam, Dob. Copy this one down. Year 8s, let's go. Let's copy this down. You're actively listening or you're actively taking notes, but you shouldn't be doing something else. 2u plus 7 equals 17. So this is my second example now. Here we go. Let's have a look at this example. Both sides, left-hand side and right-hand side, are equal to each other. Okay? Your job is to find u, the letter u. You can balance the equation however you want, as long as you can get u by itself. Now, one of the techniques that we can do is we know that BODMAS tells us the order, usually, based on this equation. Now, do I have any brackets here?
No.
No, no brackets. Do I have any indices here? U is not an indice. Indice is when you have a power. So say like that. That's an indice. Okay. No indices. What about division?
No.
No. What about multiplication?
Yes.
Yes, there is. We don't see it. But remember, 2 next to a U means multiplication. So this is the first thing you're doing. Number 1 is you're timesing by 2 to the U. And then, do we have addition? Yes, we do. We have an addition. Now, if you have a look here, we've got now add 7 is the second step. Now, if you're undoing this problem, and that's why I was trying to teach you, if you've got BODMAS, we're going to go through SAM-DOB. So what is SAM-DOB? You're going to go backwards now. You're going to try to undo all subtractions and additions first. So you're going back instead of 1, 2, now you're going 2, 1. So in this case here, you've got plus 7. I can undo this. Instead of adding 7, what's the opposite of adding 7? Subtracting 7. So remember, we're balancing the equation. You can do whatever you want as long as you do it to both sides. So here, I can say, why don't we decide to subtract 7 on the left, subtract 7 on the right? Because I'm balancing it. I'm balancing the equation. There's nothing wrong there. But what's the beauty is that we know 7 minus 7 equals what? 0. So we essentially removed it from the left. If 7 minus 7 cancels out to be 0, you end up with 2 times u is equal to 17 minus 7 is 10. So we've already undone a problem. We're almost there. We're so close. We just want to know u. We don't want to know 2u. We don't want to double u. We just want the u. So, same thing again. This is times 2. So instead of timesing it by 2, instead of doubling it, what's the opposite of times 2?
Divide.
Divide 2. So here, I'm going to divide 2. But whatever you do to one side, you do to the other side. So here we go. I'm going to divide 2 on both sides. What is 2 divided by 2 again? What's 2 divided by 2? 1. Very good. So this cancels out to be 1. And so you have 1u is equal to, and on the right hand side to balance it, 10 divided by 2, 5. Now you have u equals 5. Now you don't have to do it this way, but this is the most efficient way. This is the technique that we try to teach in class, which is called inverse operations, because it's the most efficient, but it's not the only way. You could have done it any other way. You could have been creative in any way you like, and you can still get u equals 5. It's up to you how you want to do that. Okay, and that's where the creativity and flexibility